Okay, let's picture this. You're working somewhere so cold, your breath just freezes instantly. And maybe it's a place where even a tiny spark could be, well, catastrophic. Add to that the pressure for everything to run perfectly all the time. It's not just nice to have, it's essential.
Exactly. We're talking about the real front lines of industry. Think oil rigs way up north or chemical plants. These places need way more than just your average, good enough heater to keep things running safely and warmly.
Yeah, you can't just wheel in any old portable heater.
No, that's not just inefficient. It's actually dangerous. You're gambling with profits, deadlines, and seriously, people's lives. You need something designed specifically for that extreme challenge.
And that's exactly what we're diving into today. We're going to unpack the Bulldog MFH portable fan heater series, specifically the T3 and T4 models. Our mission really is to understand how these things are engineered, how do they deliver reliable heat, how do they boost safety, and, ultimately, how do they help productivity in places where normal equipment just wouldn't last.
Right.
We've gathered insights from quite a few sources, detailing their capabilities, the engineering behind them, and where they're used. These things are industrial powerhouses.
Absolutely. So where do we start? The need itself.
Yeah, let's talk about why standard heaters are such a bad fit. We touched on extreme environments, but let's get into the nitty-gritty. Our research makes it pretty clear. Using regular heaters in places like oil and gas, utilities, chemical processing, even manufacturing, it's just asking for trouble.
It really is. You're looking at potential mechanical failure, which is bad enough,
Right.
but also fire risks or even being shut down by regulators, huge implications.
And it's not just vaguely dangerous. These areas are very specifically defined.
Oh, absolutely. The sources break this down really clearly. You've got hazardous zones categorized. For gas environments, there's Zone 1 and Zone 2, and those are further broken down into IIA, IIB, and even H2 for hydrogen specifically. And then for dust, you've got Zone 21 and Zone 22, including something called ISS. These aren't just like technical jargon. They define the exact level of risk and dictate precisely what kind of certified equipment is mandatory.
So a standard heater isn't just going to perform poorly, it could actually trigger a disaster.
Exactly. It could be the ignition source.
So this goes way beyond just keeping people comfortable. It's a fundamental issue of compliance and safety.
That's right. For the people making purchasing decisions, procurement managers, safety officers, operations directors, the sources frame this as a core responsibility. You have a duty, essentially, to ensure operations are seamless, yes, but above all, safe. No compromises.
Okay, so if standard heaters are out, what kind of solution actually meets these incredibly strict requirements?
Well, this is where the Bulldog MFH comes in. Our sources flag it as, and this is a quote, the world's first truly portable hazardous area fan-assisted heater.
Truly portable. That sounds like a big deal for deployment.
It's a game changer. And it's made by X-Hate Industrial, a name that, carries a lot of weight in this field.
And the way it's described is interesting, too. Not just a heater, but hard-hitting, cold-busting powerhouses.
Right. And they combine, quote, simplicity meets efficiency.
Which is kind of counterintuitive, isn't it? You'd think extreme capability means extreme complexity.
Sometimes. But here it seems to be about smart, focused engineering for these tough conditions. Elegance in design, perhaps?
So where do we see these being used? What industries?
It's a really broad range, actually.
Yeah.
Obvious ones like oil and gas, utilities,
Sure.
chemical plants, heavy industry, mining, offshore platforms. But also think about storage. Places storing batteries, munitions, fuel-critical stuff.
Ah, right. Highly sensitive.
Exactly. And even aircraft servicing, hangars, maintenance bays. Anywhere cold meets potential hazards.
So what's the bottom line for the people working there? What are the core benefits day to day?
Well, beyond just staying warm, which is huge,
Yeah.
the material points to real operational gains.
Yeah.
We're talking increased productivity because people aren't slowed down by the cold. Fewer disruptions overall.
Makes sense.
And just better work comfort, which shouldn't be underestimated for morale and focus. It adds up to, as the sources put it, peace of mind and productivity.
Okay, let's get into that engineering then. When you talk about these extreme conditions, the design must be pretty specialized. What really jumps out about how the Bulldog MFH is built?
The first thing, honestly, is the casing. It's not just metal. It's a steel-reinforced polymer.
Steel-reinforced polymer. What does that mean practically?
Well, it's incredibly tough, like aerospace-grade stuff.
Right.
But it's also relatively lightweight, which helps with that portability we mentioned.
Okay.
And critically, it offers EMI shielding. That protects the internal electronics from interference.
Right. And it's also anti-static.
Yes, absolutely vital. Prevents static buildup that could cause a spark in those hazardous zones. A huge safety feature.
And inside, the heating part.
That's meticulously designed too. Finned tubular elements using premium nickel chrome resistance wire. It's all compacted inside high-purity magnesium oxide powder. And here's a key detail. Each fin is fully soldered to the element tube. That significantly boosts heat transfer. You get efficient heating while staying within strict safety temperature limits.
So it's a balancing act, generating powerful heat but keeping everything contained and safe.
Precisely. Which leads us to the safety systems. They're quite advanced.
Like what?
There's a custom protection device. What's remarkable is it allows the heater to operate reliably even when the outside temperature drops to minus 40 degrees Celsius.
Minus 40, wow.
Yeah. Standard thermal cutouts would likely just trip or fail at those temperatures.
And there's more.
Oh, yes. For precise control, there's an advanced temperature sensor, an RTD sensor constantly monitoring the hottest part of the heating element itself. This ensures it never exceeds the specific T-class temperature limit for that model. We'll get into T-classes shortly.
Okay.
And there's also a dual enclosure system for the electrical components.
Dual enclosure, how does that work?
It uses two types of protection. XD enclosures, which are flame-proof, basically tiny vaults that contain any potential internal ignition, and XE enclosures, which means increased safety. These are designed to prevent sparks from forming in the first place through things like secure connections and specific spacing.
So like a belt and suspenders approach.
Exactly. Multiple layers of safety built in.
And this isn't just internal design, it's externally validated too, right? Certifications.
Absolutely critical. These
Yes.
units boast major global certifications. ATEX for Europe, IESEX for international use, and CUTR, which is also known as EAC, for the Eurasian Customs Union. Having these means they're proven to meet the stringent requirements for the world's toughest hazardous environments.
That's serious validation.
Definitely. And it's not just ticking boxes. They also have a patented design and an EU-IPO trademark registration showing genuine innovation here.
And real-world proof.
Yeah, the sources mention offshore approval, specifically highlighting successful trials in the North Sea. It's apparently become something of an industry standard out there. When it works reliably in the North Sea, you know it's tough.
Okay, let's tackle those T-classes you mentioned. Temperature classifications. They sound important, but maybe a bit confusing.
They are absolutely critical for safety and, yeah, a little counterintuitive at first glance. Basically, T1 through T6 define the maximum surface temperature the equipment is allowed to reach, even under fault conditions within a hazardous area.
Maximum surface temperature. Got it. So how does that apply to the T3 and T4 models?
Right. For the T3 model, the maximum allowed surface temperature is 200 degrees Celsius, that's 392 Fahrenheit. Because it can safely go up to 200 C, it allows for a pretty robust power output up to 6 kilowatts.
So the T3 is the powerhouse.
It's definitely a workhorse, great for general heating, keeping crews warm. It comes in various voltages, single phase, three phase, and it moves a lot of air over 1,000 cubic meters per hour, giving a decent temperature rise of around 16 to 18 degrees C. Very effective.
Okay, so then the T4 model, what's different there?
Here's where the classification gets crucial. The T4 has a lower maximum surface temperature limit, 135 degrees Celsius or 275 Fahrenheit.
Lower temperature limit. Wait, T4 is a higher number than P3, but the temperature limit is lower.
Exactly. That's the counterintuitive part. Higher T number means lower maximum surface temperature allowed, which means greater safety.
Ah, okay, so T4 is for even riskier environments.
Precisely. That lower surface temp limit means the T4 provides an enhanced safety margin, especially where you might have gases or dusts that ignite at lower temperatures. And this is non-negotiable. You cannot use a T3 rated heater in an area that specifically requires a T4 rating.
Right. Safety first. So the T4 offers more safety, but does that affect performance?
It does mean a slight reduction in power output because of that stricter temperature cap. The T4 typically goes up to about 3.7 kilowatts. It's designed, as the sources say, for ultimate hazardous area protection when you absolutely cannot leave anything to chance.
Same airflow, though.
Yes, same airflow as the T3. But because the elements can't get as hot, the actual air temperature rise is a bit more moderate, maybe 7 to 11 degrees Celsius.
So it's a trade-off. Maximum safety in the T4, slightly less heat output compared to the T3 workhorse.
Exactly. It's about choosing the right tool with the right safety rating for the specific hazard level of the environment.
Makes sense. So we've talked about the serious engineering and safety. What about actually using these things on site? Day-to-day practicality.
Well, that truly portable aspect we mentioned earlier is key. The sources emphasize they are lightweight, compact, and designed to be genuinely plug-and-play. You can get them set up and running quickly, even in awkward or remote spots. No complex installation needed.
And they're built tough, right? To handle industrial sites.
Oh yeah, that rugged housing isn't just for show. It's designed to take knocks, vibration exposure to oil, chemicals, the usual realities of harsh environments. It ensures the heating integrity holds up.
Any specific efficiency features worth noting?
Yes, the airflow is optimized with the casing shape and that patented curved element design. That helps make it more compact, but also improves the thermal transfer compared to older flat designs. Plus, they can push directed heat effectively up to about 5 meters. Good for spot heating work areas.
And simple to operate?
Very much so, according to the materials. Simple controls, intuitive functions. The idea is anyone on the team can use them quickly and safely without needing extensive training. Designed for fast-paced situations.
What about moving them around or setting them up in different ways?
They come standard with adjustable feet, which is simple but effective for stability and aiming the heat. But there are options too. You can get anti-static casters, different sizes for easier rolling.
Okay.
And there are robust mounting brackets if you want to fix them to a wall or ceiling. Available in coated steel or even stainless steel for really corrosive areas.
And ducting.
Yep. Flexible ducting is an option, typically in lengths around 7.6 meters if you need to channel the heat somewhere specific. Plus, extra safety controls like local isolators or emergency stop buttons can be added.
And environmental resilience. We mentioned the managed 40 capability.
Right. They operate reliably from negative 40 C all the way up to plus 40 C ambient temperature. That's a huge range. They also have an IP65 rating.
Which means?
Good protection against dust ingress and also against low-pressure water jets from any direction. So, pretty robust against the elements.
Any idea on noise levels?
The sources quote, around 65 decibels at 50 hertz operation, maybe 68 at 60 hertz. That's roughly like a normal conversation level. Good to know for planning.
Okay, so you've got these incredibly robust, safe, and practical heaters. Now, how do companies actually get their hands on them? The supply side matters too.
Absolutely. Choosing the right supplier for critical equipment like this is key. Our sources point towards peenergy.com. They're described as the most trusted wholesale industrial supply source in North America.
Wholesale industrial supply. What advantages does that offer buyers?
Well, several things stand out in the material. First, speed. They apparently offer fast quotes and keep ship-ready inventory. In industry, waiting weeks for essential gear isn't an option, so that's huge.
Right, downtime costs money.
Exactly. Second, they're B2B focused and proven. They understand industrial needs, the applications, the safety documentation, the purchasing processes. It's not like buying off a consumer website.
They speak the language, basically.
Precisely. Third, there's a cost aspect. By being a wholesale source, they aim to provide a total cost advantage, helping companies avoid typical contractor markups.
Direct industrial pricing.
Just the idea. And finally, expertise. They don't just sell boxes. They offer guidance and real support from actual industrial heating specialists.
So you get advice from people who know what they're talking about.
Right, someone who can help figure out the best model for a tricky application or navigate those complex safety regulations. It's more of a partnership approach.
Okay, so wrapping things up then.
Yeah.
This deep dive into the BULLDOG MFH series, the T3 and T4, it feels like the takeaway is pretty clear.
Yeah, I think so. These aren't just heaters. They are really strategic tools. For any industrial operation working in cold, hazardous conditions where you absolutely cannot afford to compromise on safety or productivity, these seem like an essential investment.
It really boils down to ensuring you can keep operating smoothly and safely no matter how tough the environment gets. Outsmarting winter, really.
And staying competitive, too. Uninterrupted operations are key.
Definitely. It's about having the right, highly engineered solution for extreme risks.
So maybe a final thought for our listeners to consider. As you think about the incredible engineering packed into these specialized heaters, what does it make you wonder about all the other unseen engineering that keeps our modern industrial world running safely and efficiently every day? You know, think about that careful balance we discussed, maximizing power output while strictly adhering to safety limits, like those T-classes. That kind of meticulous design is everywhere, often hidden, ensuring things are both powerful and safe. Makes you think, doesn't it?